I'm so glad you found your way here, right now, somewhere in the world. Whales are singing songs that travel 1,000 miles through ocean darkness. Birds are calling to mates in languages their parents taught them. And bees are dancing precise directions to flowers only they can see. Tonight, you'll discover how animals speak to each other in ways we're only beginning to understand. And by the end, you'll realize that communication connects every living thing in an invisible web of meaning. Welcome to the Sleepy Safari. Wherever you are right now, perhaps hearing the distant call of a night bird outside your window, or simply imagining the conversations happening in forests, oceans, and skies around the world. Allow yourself to settle into this peaceful curiosity. We'll explore 100 animal facts about the languages creatures use to survive, connect, and thrive. From elephants rumbling messages through the ground, to fireflies flashing love letters in synchronized light, to the chemical whispers ants leave for their sisters to follow home. These quiet explorations of nature's hidden worlds plant seeds of tranquility in searching hearts. Your gentle support helps more nature seekers find their way here and brings us closer to protect this healing ground. One sleepy soul at a time. Your presence here nurtures our growing forest of peace. Sink into your favorite resting spot. Allow your muscles to release, each breath growing softer. There's no need to hold on to these nature facts. Just notice that warm, drowsy calm washing over you, like settling into soft forest moss. The earth holding you gently, pulling you towards sleep. Close your eyes and breathe deeply. You're resting in a world where millions of conversations happen in languages you've never heard, where meaning flows through sound, light, touch, and chemistry. Let your mind settle with the knowledge that communication is everywhere, in forms beyond human words. And now we begin. Humpback whales sing the longest and most complex songs in the animal kingdom. Male humpbacks produce elaborate vocalizations that can last up to 20 minutes and are repeated for hours, sometimes even days. These songs travel through ocean water for distances exceeding 1,000 miles, carrying across vast stretches of the Pacific and Atlantic. What makes these songs remarkable is that all the whales in a particular ocean region sing nearly the same song, with small variations that change gradually over months and years. Scientists who've studied whale songs since the 1970s have documented how these melodies evolve, with new phrases being added and old ones dropping away, almost like cultural fashions passing through whale populations. The songs are believed to play a role in mating, though their exact purpose remains one of the ocean's gentle mysteries. What we do know is that whales are composers, singers, and listeners in a sonic world we're only beginning to understand. Elephants communicate using infrasound, frequencies below the range of human hearing. These low rumbles, some as low as 14 Hz, travel through both air and ground for distances up to 6 miles. When an elephant vocalizes at these frequencies, other elephants can detect the vibrations through their feet and trunk, feeling the message as much as hearing it. Research from 2024 using seismic monitoring equipment has revealed that elephants use at least 70 distinct infrasonic calls with different meanings. Some announce presence, others signal danger, and still others coordinate group movement across the savannah. Mother elephants rumble to calm frightened babies. Matriarchs broadcast warnings about approaching predators. This creates an invisible communication network across the African landscape, a conversation happening beneath the threshold of human awareness, connecting elephant families in ways that look like silence but are rich with meaning. Honeybees perform a waggle dance to tell their hive mates exactly where to find food. When a forager bee discovers flowers with good nectar, she returns to the hive and dances on the vertical honeycomb surface. The dance is remarkably precise. The angle of her waggling run, relative to straight up, indicates the direction of the food source relative to the sun's current position. The duration of the waggle phase encodes the distance. Roughly 1 second of waggling for every kilometer. Other bees crowd around the dancer, following her movements, touching her with their antennae to learn the message. Carl von Frisch decoded this dance language in the 1940s, work that eventually won him a Nobel Prize. It's geometry, astronomy, and communication combined into a movement language that's been refined over millions of years of evolution. Prairie dogs have one of the most sophisticated vocal languages discovered in non-primates. Researcher Kon Slobodchikov spent over 30 years studying prairie dog alarm calls in the American Southwest and found something fascinating. Prairie dogs don't just have one generic alarm call for predators. They have different calls for different threats. There's a specific call for hawks, another for coyotes, one for badgers, and one for humans. Research suggests prairie dogs can distinguish between different predators and may encode details about size and shape in their calls. While the full extent of their descriptive ability is still being studied, their alarm system appears more sophisticated than a simple warning cry. This suggests prairie dogs have a form of syntax, combining sounds to create new meanings. One of the hallmarks of language. It's a reminder that complex communication isn't unique to humans or even to our closest relatives. Dolphins have signature whistles that function like names. Each dolphin develops a unique whistle early in life, a sound pattern that identifies that individual. When dolphins meet, they often exchange signature whistles, essentially introducing themselves. Mother dolphins whistle their signature frequently to newborn calves, teaching them their name. Research published in 2025, using underwater microphones and AI analysis, confirmed that dolphins not only recognize each other's signature whistles, but will respond when they hear their own whistle played back to them, similar to how humans turn around when someone calls their name. Even more remarkably, dolphins copy each other's signature whistles when trying to get that individual's attention, like calling someone's name across a room. This ability to label individuals, to use arbitrary sounds as symbols for specific beings, is a fundamental building block of language. Dolphins swim through a world of names, calling to friends and family across the blue distances of the ocean. Vervet monkeys in Africa have distinct alarm calls for different predators, and young monkeys learn these calls from adults. Researchers in the 1980s discovered that vervets produce one alarm call for leopards, a different call for eagles, and a third for snakes. Each call triggers a specific escape response. The leopard alarm sends monkeys scrambling up into trees. The eagle alarm makes them look up and dive into bushes. The snake alarm causes them to stand upright and scan the ground. What's fascinating is that infant vervets aren't born knowing which call means which predator. They learn by watching adult reactions. Young monkeys sometimes make mistakes, giving the eagle alarm for a harmless bird, but adults correct them through repeated experience. By adulthood, they've mastered the alarm vocabulary. This shows that some animal communication isn't purely instinctive but learned, transmitted culturally from generation to generation. Language, in its simplest form, being taught by mothers to children in the trees. Sperm whales have regional dialects. Different groups of sperm whales, called clans, produce different patterns of clicks known as codas. These codas are distinctive enough that researchers can identify which clan a whale belongs to just by listening to its click pattern. Clans that live in the same ocean region for generations develop their own acoustic culture, a dialect that's unique to their family group. A 2024 study tracking sperm whale populations across the Pacific found that whales from different clans, even when they encounter each other, don't interbreed, suggesting that dialect acts as a social boundary, a marker of identity. Calves learn their clan's coda pattern from their mothers and other adult females, and they carry that pattern throughout their lives. The ocean is divided not just by currents and temperature, but by invisible borders of sound, dialects that tell whales who their people are, which family they belong to in the vast, dark sea. Parrots can learn human words, but in the wild, they have their own complex vocalizations that vary between flocks. Recent research from the Amazon rainforest, documented in 2025, shows that different parrot flocks have distinct contact calls, sounds they use to identify members of their group. When parrots leave the nest as juveniles, they don't automatically know their flock's call. They learn it from their parents and flock mates, and they adjust their vocalizations to match the group. If a parrot moves to a different flock, it will gradually change its call to fit in with the new group's dialect. This vocal learning ability, rare in the animal kingdom, is what allows parrots to mimic human speech so effectively. But in their natural environment, they're not mimicking us. They're maintaining flock identity through learned calls, creating acoustic communities that echo through the rainforest canopy. Every parrot carries the voice of its flock, a living record of where it belongs. Ants communicate primarily through chemicals called pheromones. When an ant finds food, it lays down a pheromone trail as it walks back to the nest, creating a chemical breadcrumb path for other ants to follow. The more ants that walk a successful trail, the stronger the pheromone signal becomes, creating a positive feedback loop that guides the colony to resources efficiently. But ants have dozens of different pheromones for different messages. There are alarm pheromones that signal danger, recruitment pheromones that say, "Come help with this task," and queen pheromones that maintain colony structure. Some ant species can even distinguish between pheromone trails that are a few minutes old versus a few hours old, allowing them to prioritize fresh information. Research published in late 2024 using microsensors found that ants adjust their chemical messages based on context, laying down different combinations of pheromones depending on the type of food found or threat encountered. It's a language written in scent, constantly evaporating and being refreshed. A conversation painted on the ground. Crows recognize individual human faces and share that information with other crows. In a University of Washington study, researchers wore distinctive masks while capturing crows for banding. The captured crows learned to scold these masked individuals. But remarkably, other crows who were never captured began scolding the same masks. They had learned from their flockmates that these specific humans were dangerous. Studies confirmed this wasn't random. Crows were communicating detailed information about individual people. This ability to transmit knowledge about specific threats across a social network is sophisticated. Crows don't just react, they warn each other, sharing information that protects the community. In cities worldwide, crows discuss us, passing warnings through their networks in calls and gestures we barely notice. Fireflies use bioluminescent flashes as a visual language for courtship. Different firefly species have different flash patterns, almost like Morse code, with specific rhythms and intensities that help them find mates of their own species on warm summer nights. Males fly through meadows, flashing their species-specific pattern, while females perched in grass respond with precisely timed flashes if they're interested. In some species, particularly in Southeast Asia, thousands of fireflies synchronize into coordinated displays, entire trees blinking in perfect unison. Research tracking firefly populations in 2025 found that light pollution from human cities is interfering with this language, making it harder for fireflies to see each other's signals. But in dark, protected areas, the summer nights still fill with their conversations. Thousands of tiny lights writing messages in the air, a silent dialogue of flashes that's been happening for millions of years. Each blink is a word, each pattern a sentence, and together they create one of nature's most visible languages, spoken entirely in light. Wolves howl to maintain pack cohesion and communicate across long distances. A wolf's howl can be heard up to 6 miles away in forest terrain and up to 10 miles in open tundra. Each wolf has a distinctive howl, recognizable to other pack members, and wolves often howl in chorus, with individuals harmonizing at different pitches to create a layered sound. Research on wild wolf packs has shown that howling serves multiple functions. It helps separated pack members find each other. It announces territory to neighboring packs, and it strengthens social bonds through communal vocalization. Before a hunt, wolves sometimes engage in group howling sessions that seem to coordinate the pack and build excitement. Studies published in 2024 found that wolves adjust their howls based on who's listening. When howling to pack members, the calls are different from howls directed at rival packs, suggesting intentional communication rather than just instinctive noise. In the howl, we hear language in its ancient form, sound used to connect, to claim, to belong. Chimpanzees use a combination of vocalizations, facial expressions, and gestures to communicate, with research showing they have at least 60 distinct gestures with specific meanings. A raised arm might mean climb on me, a gentle touch, come with me, or a leaf clipping sound made with the mouth signals courtship interest. Jane Goodall's decades of observation revealed that young chimps learn these gestures by watching older chimps, and that usage can vary slightly between different chimpanzee communities, suggesting cultural transmission. Recent studies using video analysis and machine learning have begun cataloging these gestures systematically across different populations, confirming that chimps combine gestures with vocalizations to create more complex messages. For instance, a specific grunt combined with a hand gesture might mean "let's groom," while the same grunt without the gesture means something else entirely. This layering of communication modes, this combining of signals to refine meaning, edges very close to syntax, the grammatical structure that defines human language. Chimpanzees remind us that we're not the only apes trying to express complex ideas. Bats echolocate, producing ultrasonic calls and listening to the echoes to navigate and hunt in complete darkness. But echolocation is more than just sonar. It's also communication. Different bat species produce different call frequencies and patterns. And individuals within a species can recognize each other by their unique echolocation signatures. Mother bats find their pups in crowded caves containing millions of individuals by recognizing their baby's specific call. Research in 2025, using advanced acoustic analysis, found that some bat species adjust their echolocation calls when flying in groups to avoid jamming each other's signals, essentially taking turns or shifting to different frequencies. This acoustic cooperation allows bats to hunt together without interfering, a kind of respectful conversation happening in frequencies we cannot hear. The night sky is filled with bat language, a symphony of ultrasonic clicks that map the world and connect mothers to children, hunters to prey, individuals to their colony in the vast darkness. Octopuses change color and texture to communicate mood and intention. While often thought of as solitary creatures, octopuses do interact with each other, and their skin serves as a dynamic communication display. When agitated, an octopus might flash dark colors and raise its arms to appear larger. When courting, colors soften, and patterns ripple across the skin in waves. Research in Australian waters documented in 2024 found that octopuses even use color patterns to deceive, showing threatening displays to rivals on one side of their body, while simultaneously displaying calmer colors to potential mates on the other side. This is remarkable because it suggests not just reactive color change, but intentional, context-specific communication. The octopus's skin is essentially a billboard, constantly updated with messages visible to any creature with eyes to see. A language of chromatophores, expanding and contracting to paint emotions and warnings in real time. Domestic cats have developed specific vocalizations to communicate with humans that they don't use with other cats. Adult cats rarely meow at each other in the wild. Meowing is primarily something kittens do to get their mother's attention. But house cats meow at humans constantly. And research shows they've adapted these sounds to manipulate us effectively. A 2009 study found that cats embed a high-frequency sound within their purrs, similar to a baby's cry, that humans find very difficult to ignore. Recent observations suggest cats learn which meows get which responses from their owners and adjust their vocalizations accordingly. Your cat is essentially learning your language, figuring out which sounds make you provide food, open doors, or give attention. It's a form of interspecies communication that evolved through domestication, with cats developing a special dialect just for talking to us. Lyrebirds are master mimics, capable of imitating chainsaws, car alarms, camera shutters, and the calls of dozens of other bird species. Native to Australia, male lyrebirds perform elaborate courtship displays that include singing complex songs composed of both their own calls and perfect imitations of everything they've heard in their forest territory. The purpose isn't random showing off. Research suggests that the complexity and accuracy of a male's mimicry repertoire signals his age, experience, and quality as a mate. A bird that can imitate 20 different species has been around long enough to hear them all, has a good memory, and possesses the neural control to reproduce those sounds precisely. Recent studies documented in 2025 found that lyrebirds in different forests have different repertoires, reflecting the acoustic environment they grew up in. A lyrebird's song is essentially its autobiography, an audio catalogue of every sound that shaped its life, sung back to the forest as proof of experience. Elephants can distinguish between different human languages and associate them with levels of threat. A study conducted in Kenya found that elephants reacted with fear to recordings of Maasai men speaking, because Maasai herders sometimes come into conflict with elephants, but showed no fear response to recordings of Kamba men speaking, an agricultural group that poses no threat to elephants. Even more remarkably, the elephants distinguished between Maasai men, women, and boys, reacting most strongly to adult male voices. This demonstrates that elephants not only process human language as meaningful sound, but associate specific linguistic patterns with specific threat levels. They're not just hearing noise, they're categorizing, analyzing, and making decisions based on linguistic cues. Elephants have learned to read us through our voices, understanding on some level that the sounds humans make carry meaning and danger. Hyraxes, small rabbit-sized mammals from Africa and the Middle East, sing complex songs that have regional dialects and change over time in ways similar to human music. Male hyraxes produce elaborate songs lasting several minutes, composed of distinct parts like verses and choruses. Research analyzing decades of hyrax song recordings found that songs evolve gradually across generations, with new elements being added and old ones modified. Different hyrax populations, separated by geography, develop distinct song dialects. And these dialects are stable within a region but change when you travel to a different area. Scientists studying hyrax songs have noted gentle parallels to human music, including patterns of repetition, variation, and theme development. Why these small animals evolved such sophisticated vocalizations remains partially mysterious. But it reminds us that music, that universal human expression, might have ancient roots in animal communication, stretching back through evolutionary time to ancestors we share with creatures much simpler than ourselves. Cuttlefish produce traveling waves of color across their bodies, a form of visual communication that scientists are only beginning to decode. These waves, moving from head to tail or side to side, appear during courtship and aggressive encounters. Recent research using high-speed cameras and computer analysis has started to catalog different wave patterns and their contexts. Some waves seem to signal aggression, others appeasement, still others sexual interest. What makes this communication fascinating is its dynamic nature. Unlike a static color pattern, a wave is temporal. It exists in time, more like a gesture or a sound than a fixed signal. Cuttlefish watching each other aren't just reading colors. They're reading movement, rhythm, speed, watching a message unfold across living skin. It's visual language in motion, communication as performance, meaning conveyed through the grammar of waves. Gibbons, small apes from Southeast Asian forests, sing duets with their mates. Mated pairs produce elaborate songs where male and female parts interlock precisely, creating complex musical phrases that echo through the forest canopy at dawn. These duets serve to announce the pair's territory to neighbors and to strengthen the bond between mates. Research on gibbon pairs has found that the quality of duet coordination correlates with relationship stability. Pairs that sing together well, with precise timing and little overlap, tend to stay together longer. Young gibbons learn their species' song structure from their parents, but the specific duets they eventually sing with their own mates are unique to each pair, developed over time through practice and coordination. It's collaborative music making, communication that requires cooperation, listening, and adjustment. In their songs, we hear the origins of human music, the joy of creating sound together, voices blending into something neither could produce alone. Naked mole rats, the unusual, nearly hairless rodents that live in underground colonies, have been discovered to have distinct dialects between different colonies. Research published in 2024 found that each colony develops a unique vocal signature, a specific variation in their soft chirping calls that members learn as pups. When researchers cross-fostered pups between colonies, the young mole rats adopted the dialect of their new colony, proving the sounds are learned, not genetic. This dialect serves as a colony identification system. When foreign mole rats with different dialects try to enter a colony, they're often rejected or attacked. While colony members with the correct dialect are accepted, it's a vocal password system, evolved to maintain colony cohesion and prevent infiltration by outsiders in the dark tunnels, where visual identification is impossible. Language as boundary, as family marker, as the sound of belonging. Hummingbirds produce songs with surprisingly complex syntax. Male hummingbirds sing to defend territory and attract mates, and their songs contain distinct syllables arranged into phrases, which are then arranged into songs lasting several seconds. Research using acoustic analysis has identified that individual hummingbirds can have repertoires of multiple song types, and they choose which song to sing based on context. When confronting a territorial intruder, they sing aggressive songs with harsher notes. When courting, they switch to softer, more complex melodies. Some hummingbird species have even been observed learning new song elements from neighbors, creating local song cultures. For birds that weigh less than a nickel, their linguistic sophistication is remarkable. A reminder that brain size doesn't necessarily limit communication complexity. Tiny aviators, defending their flower territories with elaborate compositions, singing at speeds faster than our ears can fully process. Killer whales, or orcas, have matrilineal cultures based primarily on learned vocalizations. Each orca pod has a unique dialect of calls, and calves learn these calls from their mothers and other pod members during their first year of life. Different orca populations, even those that share the same waters, can have completely different dialect, and orcas from different dialectical groups rarely interact or interbreed. Research tracking orca populations across the Pacific has documented that these dialects remain stable across decades, passed from grandmothers to mothers to calves in an unbroken chain of cultural transmission. The calls themselves are complex, including discrete calls, whistles, and clicks, with some populations having over 30 distinct call types. When an orca vocalizes, it's not just communicating, it's affirming identity, belonging to a specific family line that stretches back generations. The ocean remembers, and the whales sing that memory forward. Zebra finches learn songs from their fathers through a process remarkably similar to how human children learn language. Young male finches listen to their father sing, memorizing the song's structure during a sensitive period in early development. They then practice, producing imperfect attempts that gradually improve through repetition and self-correction. Research using neural recordings has found that zebra finch brains have specialized regions for song learning and production, analogous to language areas in human brains. If a young finch is raised without hearing adult song, it will still sing. But the song will be simpler, less structured, lacking the refinement that comes from cultural transmission. Studies published in 2025 have shown that when young finches make mistakes in their practice, they detect those errors and adjust, demonstrating metacognition, an awareness of their own performance. In tiny bird brains, we see the neural foundations of language learning, ancestors of the circuits that eventually allowed humans to speak. Let's pause here and imagine you're lying in a rainforest at dusk, surrounded by the sounds of countless conversations. Bird calls echo through the canopy. Insects buzz and click in rhythmic patterns. Somewhere distant, a howler monkey roars its territory claim. Frogs begin their evening chorus. All around you, life is unfolding in its ancient patterns of communication. Each sound carries meaning to the creatures who speak and listen. Messages about danger, food, territory, love, survival. You're not separate from this place. You breathe the same air these animals breathe. You're made of the same elements, the same carbon, the same ancient stardust. Feel yourself held by the earth, supported by the ground, connected to every living thing through invisible threads of kinship. Notice how your breathing has slowed, how your body feels heavier, how thoughts drift like falling leaves. Now we continue our journey together. Sea otters use tools and have been observed teaching these skills to their young through demonstration and allowing practice. While tool use itself is remarkable, what's more interesting for communication is how these skills spread through otter populations. Research in California monitored otter populations over multiple generations and found that tool-using techniques cluster in family groups, suggesting vertical cultural transmission from mothers to pups. But occasionally, new techniques appear and spread horizontally through a population, suggesting otters also learn by watching non-relatives. This means otters have informal teaching happening, where skilled individuals tolerate observation and novices learn through watching. It's non-verbal communication of complex information, knowledge passing between individuals without language, but through the universal grammar of demonstration and imitation. Show, watch, practice, learn. A curriculum written in behavior instead of words. African grey parrots can learn not just words, but concepts. The famous parrot Alex, studied by researcher Irene Pepperberg for 30 years until his death in 2007, could identify objects, colors, shapes, and quantities, and could request items using English words appropriately. More remarkably, Alex could answer questions about objects he'd never seen before. If shown a key and asked what color, he would correctly answer. He understood that the word color referred to a property of objects, not just a memorized response to a specific item. Recent research with other African greys has confirmed they can perform similar cognitive feats, suggesting Alex wasn't unique, but representative of his species' abilities. These birds aren't just mimicking sounds. They're using words as symbols for concepts, a fundamental aspect of language. When a parrot says "want grape," it's not random. It's a request, a communication of desire using learned symbols. The boundary between animal communication and human language grows hazier with every trained parrot. Wolves use body language as extensively as vocalization, with subtle postures communicating dominance, submission, playfulness, and intention. A wolf approaching with ears forward, tail raised, and direct eye contact is asserting dominance. The same wolf approaching with ears back, tail lowered, and gaze averted is showing submission. Play bows, where the front end lowers while the rear stays up. Signal this is play, not aggression, allowing wolves to engage in rough mock fights without escalating to real violence. Researchers studying wild wolf packs have catalogued dozens of distinct postures and gestures, each context-dependent, each conveying specific information. What makes this communication sophisticated is its subtlety and grammar. The meaning of a gesture changes based on what gestures preceded it and what follows, creating sequential information flow similar to sentences. Two wolves can have an entire conversation without making a sound, negotiating rank, resolving conflict, or coordinating action through the silent language of the body, meaning made visible in muscle and motion. Dolphins synchronize their movements to strengthen social bonds, a form of non-verbal communication that creates group cohesion. When dolphins swim together, they often match each other's movements precisely, surfacing to breathe at the same moment, diving in unison, even mirroring each other's body positions. This synchronization isn't accidental. Research using underwater cameras and motion tracking has shown that dolphins actively adjust their swimming to match companions, and that synchronized pairs and groups have stronger social bonds than non-synchronized individuals. Synchrony is communication without information content in the traditional sense. It doesn't convey a message like danger or food here. Instead, it says we are together. We are one unit. It's the language of belonging, of solidarity. Connection made tangible through matched movement. Humans do this too, unconsciously mirroring people we like, marching in step, dancing together. The roots of that behavior stretch deep into our mammalian past, to ancestors who knew that moving together meant surviving together. Crows hold what can only be described as funerals. When a crow dies, other crows gather around the body, calling loudly, sometimes for hours. Researchers studying this behavior found that crows remember the location of dead crows and avoid those areas for weeks afterward. But the gathering isn't just about learning dangerous locations. It appears to be a social event where information is shared. Studies published in 2024 using tagged crows and surveillance cameras showed that crows present at these gatherings behave differently afterward, exhibiting heightened caution and passing along alarm calls more frequently. The dead crow serves as a teacher. Its death, a lesson observed and communicated by the living. Through their gatherings, through their calls, crows spread the knowledge. Something dangerous happened here. The funeral becomes a form of distributed learning, information transmitted through social ritual, a culture of caution maintained through communal mourning. They remember, they warn, they teach the dead's final lesson to the living. Honeybees communicate the quality of a food source through the intensity of their waggle dance. A bee returning from mediocre flowers performs a half-hearted dance, barely wiggling. But a bee that found excellent nectar performs with vigor and enthusiasm, waggling vigorously, dancing longer, recruiting more followers. Other bees assess these performances and choose which dancer to follow based on apparent excitement. Recent research has shown that bees essentially vote on food sources through this dancing. Multiple foragers might report different locations, but eventually the hive converges on the best option as more and more bees follow the most enthusiastic dances. This is collective decision-making through communication, a democracy of dancing, where the most valuable information naturally rises to prominence through the intensity of its presentation. The hive doesn't need a leader to decide where to forage. The language itself contains a mechanism for consensus, built into the grammar of movement. Male peacock spiders, tiny Australian arachnids smaller than a grain of rice, perform elaborate courtship dances, combining movement, color, and vibration. The male raises his decorated abdomen, unfurls brilliant colored flaps, and dances in specific patterns while vibrating the ground to create sound. Different peacock spider species have different dance routines, and females judge males based on performance quality. Research using high-speed cameras has revealed that these dances are incredibly complex, with males incorporating jumps, leg waves, and abdomen wiggles in precise sequences. Females watch critically, and most males are rejected. What the female is evaluating isn't entirely clear, but it seems to be a combination of color brightness, pattern symmetry, and dance precision, all indicators of male health and genetic quality. The dance is a language of fitness, a visual and vibrational argument for mating, one of nature's most elaborate conversations conducted by one of its smallest dancers. Elephants use their trunks to greet each other, with different greeting gestures indicating different relationships. When close family members meet after separation, they intertwine trunks, exploring each other's mouths, a gesture of deep affection and recognition. More distant acquaintances touch trunks briefly. Elephants also place their trunks in each other's mouths, a sign of trust and submission, often seen in calves greeting adults. These trunk gestures are accompanied by rumbles, ear flapping, and temporal gland secretions, creating multimodal communication that conveys identity, emotion, and social status simultaneously. Research on wild elephant herds has documented that elephants remember individuals for decades and adjust their greetings based on relationship history. A matriarch meeting her grown daughter after months apart will greet her differently than she greets a stranger from another herd. The trunk becomes a hand, a voice, a chemical signal transmitter, a Swiss Army knife of communication that allows elephants to express the complexity of their social world in touch and sound. Cuttlefish males can display two different color patterns simultaneously on opposite sides of their body. When a small male approaches a guarded female, he sometimes shows aggressive male coloring on the side, facing the large guardian male, while displaying female courtship colors on the side facing the female. This deception allows the small male to court the female while the guardian thinks he's seeing another female, not a rival. Research documented in 2025, using cameras positioned on multiple sides of courting cuttlefish, confirmed this behavior occurs regularly. What's remarkable is the intentionality implied. The cuttlefish isn't just reflexively responding to stimuli. It's managing information flow to different audiences, showing each observer a different message. This is sophisticated communication, using the same medium, color change, to construct different lies for different viewers, simultaneously Deception as language. Appearances managed like words chosen carefully for effect. Bottlenose dolphins help injured or sick pod members breathe by supporting them at the surface. But beyond the physical help, the pod communicates constantly during these rescues. Dolphins whistle to the injured individual, make physical contact, and coordinate their movements. Research observing these events has noted that the vocalizations during rescues are often signature whistles, dolphins calling to the injured individual by name, essentially saying, "We're here. You're not alone." This behavior suggests not just instinctive helping, but empathetic communication, an attempt to provide comfort through familiar sounds. The dolphins may not understand death conceptually, but they understand distress, and they respond with the tool they have: their voices, their names, calling to each other in crisis. Language at its most fundamental, not conveying information but connection. "I am here. You are not alone. Keep breathing. We will help you." Chimpanzees laugh. Their laughter sounds different from human laughter, more breathy and staccato, but it serves the same social function, signaling play, joy, and non-aggression. Young chimps laugh when tickled, when play fighting, when chasing each other through the trees. The laughter is contagious. When one chimp laughs, others nearby often join in. Research comparing chimpanzee laughter across different populations has found slight variations, suggesting laughter, like other chimp vocalizations, has a learned cultural component. What's most interesting is that laughter appears in many primate species, including bonobos, gorillas, and orangutans, suggesting it's an ancient form of communication that predates human evolution. Our laughter, that uniquely human sound of joy, has roots stretching back millions of years to ancestors who played in trees and needed a signal to say, "This is fun. Keep going. Don't stop." The same message, across species, across time. Sperm whales use a specific sequence of clicks, called a coda, to identify themselves to other whales. Recent research, using artificial intelligence to analyze thousands of hours of sperm whale recordings, has begun to reveal what researchers believe might be structure within whale language. A study published in 2024 by researchers at MIT found that sperm whale codas have complex internal patterns, with variations in rhythm and emphasis that could potentially encode different meanings. The AI identified what researchers are cautiously calling elements of a sperm whale communication system, basic components that whales combine in different ways to create different codas. If this interpretation continues to be supported, sperm whales might have combinatorial communication, the ability to combine basic elements to create various meanings. A key feature of human language. We're still decoding their messages, but we're beginning to suspect that in the ocean's darkness, whales are having conversations far more sophisticated than we imagined. Leafcutter ants use antennae touches to communicate about trail conditions. When an ant walking on a pheromone trail encounters an obstacle, it stops and touches antennae with the next ant coming from the opposite direction. These antennal contacts convey information about trail quality. Research using video microscopy found that ants adjust their speed and recruitment behavior based on these touches. If many ants are reporting obstacles, the trail is temporarily downgraded and fewer ants are recruited, allowing time for the path to clear or for scouts to find better routes. This is real time, context-dependent communication. Information flowing through a network of physical touches. Each ant, both sender and receiver. The colony's decision-making distributed through thousands of tiny conversations, happening antenna to antenna, body to body. In the dark pathways beneath the forest floor, ravens plan for the future and can communicate about events that haven't happened yet. In experimental settings, ravens have demonstrated the ability to choose and save tools they'll need later, foregoing immediate rewards for future benefits. They can also understand that a human is planning to give them food and will wait patiently, even alerting other ravens to the coming meal through vocalizations and gestures. A 2024 study showed that ravens can communicate about absent objects and anticipated events, essentially talking about things not immediately present. This is called displacement, the ability to refer to things removed in space or time, another hallmark of human language. When a raven caws to its mate about food that will be available tomorrow in a location neither bird can currently see, that's language transcending the immediate present. Thought traveling through sound into possibility. Domestic dogs have evolved the ability to read human communicative gestures better than wolves or even chimpanzees. When a human points at something, most dogs will look where the person is pointing, understanding that the gesture indicates something worth attending to. Wolves, raised by humans, don't do this reliably. And chimpanzees, our closest relatives, also struggle with the task. Dogs, through 15,000 years of domestication, evolved to understand human communication specifically. Research has shown that this ability appears in puppies before significant training, suggesting genetic changes. Dogs have developed a special relationship with human language, not through speech, but through gesture reading, understanding what we mean when we point, when we look, when we gesture. They learned our language in the way that mattered most to them, becoming fluent in the dialect of human intent. If you're still awake, still wandering through the world of animal language with us, that means your curiosity hasn't rested yet, and that's perfectly okay. Take a gentle breath. Feel yourself held by the earth, just like the animals we've been exploring are held by their habitats. Connected through communication, invisible and visible, sound and silence. We're exploring nature's conversations together. Every fact is another step deeper into peaceful territory, and we'll keep going, slowly, until sleep catches up to you. Let's drift onward. Every conversation in nature, from the smallest to the grandest, follows a gentle pattern. One being creates a signal, a sound, a gesture, a flash of light. That signal points to something real, danger or food or love. Another being receives the signal and understands. This simple dance of meaning connects all communicating life, from bees to whales to the words you're hearing now, falling softly into sleep. A vervet monkey's eagle alarm is a signal. The eagle itself is what the signal points to. Other vervets, understanding that the alarm means eagle, complete the circle. This basic structure exists across the animal kingdom, from bee dances to whale songs, from elephant rumbles to crow warnings. What varies is complexity, but at the foundation, all communication is this: making a pattern that points to something else, and having that pattern understood by another mind. Language, at its core, is shared meaning, the miracle of one consciousness reaching across space to touch another. Learning appears essential for the most complex communication. Animals with the most sophisticated communication systems: dolphins, whales, elephants, apes, parrots, crows, all have extended childhoods where young individuals learn from adults. The more complex the communication, the more teaching and practice seems required. A cricket's chirp is mostly innate, genetic, requiring little learning. A humpback whale's 20-minute song must be learned, memorized, practiced. This pattern appears throughout nature, suggesting that language evolves hand in hand with intelligence and social structure. The smartest animals, the ones who need to coordinate complex social groups, develop the most elaborate languages. And those languages, in turn, allowed even greater social complexity. It's a gentle spiral language enables cooperation. Cooperation rewards better language. Better language enables more complex cooperation. Each element reinforces the others, building toward the communication systems we see today. Deception appears in animal communication, suggesting intentional manipulation rather than just reflexive signaling. Capuchin monkeys give false alarm calls to scare rivals away from food. Male fireflies of some species imitate the flash patterns of other species to lure females, then eat them instead of mating. Cuttlefish, as mentioned earlier, display false colors. This deception is interesting because it implies that animals understand that their signals affect other animals' behavior and that they can deliberately send false signals for benefit. The signal has become unmoored from what it represents. The monkey knows there's no predator, yet it gives the alarm call anyway, because it knows the alarm will cause a specific response it can exploit. This is theory of mind in action. Understanding that others have beliefs that can be manipulated through communication. Lying, that most human of behaviors, has roots in animal communication. Wherever the costs of honesty exceeded the benefits of truth. Birdsong and human music share deep structural similarities. Both use pitch, rhythm, and repetition. Both organize sounds into phrases and larger compositions. Both are learned through imitation during sensitive periods in youth. Both show regional variation, dialects and styles that differ by geography. Recent research in neuroscience has found that bird brains and human brains process song and music using similar neural circuits, suggesting these similarities aren't coincidental, but reflect deep commonalities in how vertebrate brains handle complex sequential sounds. A study published in 2025 using brain imaging on zebra finches found activity patterns remarkably similar to humans listening to music, including areas associated with emotion and reward. This suggests that music, that universal human cultural feature, might have evolutionary origins in territorial bird songs, that when our ancestors developed language, they borrowed and elaborated on neural mechanisms already used by birds for millions of years. Music as ancient communication, predating words. Multimodal communication, using multiple sensory channels simultaneously, increases message reliability. Elephants combine infrasound rumbles with visual displays like ear spreading and physical touches. This redundancy ensures the message gets through, even if one channel fails. If you can't hear the rumble, you see the ears. If visibility is poor, you feel the vibration. Evolution tends to add communication channels for important messages. Courtship often involves visual displays plus vocalizations plus chemical signals. Alarm calls are often accompanied by visual startle responses and rapid movement. The more important the message, the more ways it's sent. Human language does this too. We don't just speak, we gesture, use facial expressions, modulate tone. Our words are wrapped in a package of non-verbal signals that modify and enrich meaning. Animal communication taught us that lesson first, important messages deserve multiple channels. Redundancy against failure, ensuring the message reaches its destination intact. Some form of communication exists in almost every organism complex enough to interact with others. Even bacteria release and detect chemical signals to coordinate behavior in biofilms. Plants release chemicals when damaged by herbivores, warning neighboring plants to prepare defenses. Fungi form vast underground networks that might facilitate information sharing between trees. Communication, broadly defined, is life's way of responding to the not-self, of acknowledging that other entities exist and that interaction with them requires information exchange. The more complex the organism, the more elaborate the communication. But the basic impulse is universal: send signals, receive signals, adjust behavior. We're all doing it. From bacteria to blue whales. In a planetary conversation older than bones, older than brains, old as life, responding to life. The evolution of communication reflects a balance between sender and receiver interests. When their interests align, communication tends toward honesty. When they conflict, communication becomes negotiation. Sometimes honest, sometimes deceptive. A baby bird begging for food benefits both baby and parent if the baby is truly hungry. So the begging is honest. But if babies always begged, regardless of hunger, parents would waste energy feeding satiated offspring. So parents evolved to ignore excessive begging. This guides babies to call when they truly need care, creating balance between parent and child. This gentle negotiation unfolds across nature, each species finding its own equilibrium between sender and receiver. Communication isn't static, it's alive, constantly evolving as senders and receivers co-evolve in a dance of connection and self-interest, honesty and strategy. Human language likely evolved from a combination of several pre-existing communication systems. Our gestures might come from great ape manual signals. Our emotional vocalizations, laughter, crying, might stem from primate alarm calls and contact calls. Our capacity for vocal learning might share ancestry with songbird neural circuits. Our use of arbitrary symbols might have roots in the animal calls that refer to specific things, like for vet eagle alarms. Language didn't appear from nothing. It was assembled piece by piece, each component borrowed from older systems, recombined and elaborated through evolutionary time, until something different gradually developed: grammar. Syntax, the ability to combine finite symbols into infinite meanings. But every piece has a history, a precursor in animal communication that stretches back through our evolutionary past. When we speak, we're using tools older than our species, refined and repurposed, but still bearing the marks of their ancient origins. The more social an animal, generally the more complex its communication. Solitary animals like tigers need only occasional signals for mating and territory. Social animals like wolves need constant communication to coordinate hunts, maintain hierarchy, care for young, defend territory. Highly social species like elephants, dolphins, and primates have the most elaborate communication systems. This pattern suggests that language evolves in response to social need. Complex societies require information flow to function. Who's in charge? Where's food? Is there danger? Who belongs to our group? These questions become more numerous and nuanced as group size grows. Communication expands to handle the load, developing new signals, new combinations, new contexts. Human language, the most complex of all, evolved in lockstep with our increasingly complex social groups. We needed language to manage our societies, and language allowed our societies to grow more complex in a gentle spiral that eventually gave us grammar, poetry, science, philosophy, all the elaborations of meaning that grow from the simple root of needing to tell each other what's happening and what to do. All communication is, at its heart, an attempt to reach across the barrier of individual consciousness. You are alone in your mind. I am alone in mine, but through signals, patterns, sounds, gestures, we can create shared understanding, can make our separate worlds overlap just slightly, just enough to coordinate, to connect, to survive, sometimes even to love. Every animal calling in the night is reaching out, trying to be heard, trying to affect another consciousness. Whether it's a whale singing to a potential mate 100 miles away, or a cricket chirping to announce its presence, or a mother elephant rumbling to her calf to stay close, it's the same fundamental act, broadcasting self into the world, hoping for reception. Language is the technology of not being alone, and every species that evolved it, in whatever form, did so because the benefits of connection outweighed the costs of isolation. We all need to be heard. That need is older than humanity, older than mammals, older than bones. It's the need of life itself, reaching toward other life across the void. Halfway through our journey, breathe slowly and imagine this. You're in a forest at twilight, in that liminal time when day creatures are settling and night creatures are waking. The air is filled with transition, with farewells and greetings, spoken in chirps and hoots and rustles. Imagine the animals around you, going about their lives. A mother bird calling softly to her nestlings, a doe communicating through scent to warn others of a pathway to take, bats beginning their ultrasonic conversations as they leave their roosts. You're not disturbing them. You're part of the scene, accepted, safe, belonging. Feel the temperature of this place. Cool air settling into the valley. Hear the layers of sound, the near sounds, the far sounds, each carrying meaning to someone. Each part of a vast network of information flowing through the forest like invisible rivers. Everything is exactly as it should be. Now we continue, together, through their world. Human babies babble before they speak, making meaningless sounds that gradually shape into words. Songbird chicks do the same thing, producing what researchers call subsong, poorly formed vocalizations that slowly crystallize into species-specific songs through practice and feedback. This parallel suggests that vocal learning, regardless of whether it produces speech or song, requires a developmental period of playful experimentation. The baby is practicing the motor control needed for language production. The bird chick is practicing breath control, syringeal muscle coordination, timing. Both are learning to match what they hear with what they produce, slowly calibrating output to model. This shared developmental pathway hints at deep connections between language, music, and vocal learning across species, all drawing on similar neural mechanisms that evolved long before humans began speaking. Dogs can learn to associate hundreds of human words with objects and actions. The border collie, Chaser, studied until her death in 2019, knew over 1,000 words, could retrieve specific toys by name, and could learn new words through inference. If Chaser knew 9 toys in a group and you asked for Darwin, a 10th name she'd never heard, she would correctly bring the one unfamiliar toy, inferring that the new word must refer to the new object. This is fast mapping, the same process human children use to rapidly acquire vocabulary. Dogs aren't just memorizing sound-object pairs through repetition. They're understanding that words refer to things and using logic to figure out which words refer to which things. This capacity suggests dogs have some of the fundamental cognitive abilities that underlie language, even though they lack the vocal apparatus to produce speech themselves. Language reception doesn't require language production. Dogs understand us better than we usually realize. The calls of some monkeys show hints of proto-syntax, combining calls in sequences that create new meanings. Campbell's monkeys in Africa produce boom calls to indicate general disturbance and crack calls for leopards. But they can combine these. Boom, boom, crack, crack means something different than crack, crack alone. Research, published in 2024, analyzing hundreds of hours of Campbell's monkey calls, found evidence that call meaning depends on sequence and context, not just the individual calls themselves. This is composition, building complex meanings from simpler elements. A step toward grammar. It's not full syntax as we know it in human language, but it's more than simple one-to-one signal meaning correspondence. It's language beginning to discover that combinations of sounds can mean more than individual sounds, that order matters, that structure carries information. Elephants can recognize the call of an individual elephant they haven't heard in decades. Researchers tested this by playing recordings of elephants who had left the herd 20 years earlier. The listening elephants reacted with recognition behaviors, orienting toward the sound, showing excitement, sometimes rumbling in response. This long-term vocal memory is remarkable and suggests that elephant social networks are maintained through sound, even across vast separations in time and space. An elephant's mind holds a library of voices, hundreds of individuals catalogued and remembered, each voice connected to a history of interactions, relationships, stories. When an old friend's voice plays from a speaker, the elephant remembers. That voice carries a past, a relationship, a story, memory, and language intertwined. Sound is the key that unlocks decades of social history. Birdsong dialects shift gradually across geography, creating dialect chains where neighboring populations sound similar, but distant populations sound different. This pattern is called clinal variation, and it's also seen in human language. Drive 100 miles, and accents shift slightly. Drive 1,000 miles, and you're hearing a different dialect. The mechanism is the same. Imperfect learning and local innovation create variation, while proximity maintains similarity. Young birds learn songs from nearby adults, making small copying errors. Those errors accumulate differently in different locations, creating divergence. The pattern reveals that any learned communication system, whether bird song or human language, will fragment into dialects given time and space. As local variations accumulate into distinct traditions, language diversifies like life itself, branching, mutating, creating beauty through variation. Some primates have theory of mind, the understanding that others have beliefs and knowledge that might differ from their own. Chimpanzees behave differently, depending on whether they think another chimp knows where food is hidden. If a dominant chimp saw where food was hidden, a subordinate won't approach it. But if the dominant chimp wasn't present during hiding, the subordinate assumes the dominant doesn't know and might take the food. This understanding that others have knowledge states is crucial for complex communication. You can't lie effectively without knowing that the listener believes things that might not be true. You can't teach effectively without understanding that the learner doesn't know what you know. Theory of mind allows communication to become strategic, referential, truly informative. It transforms communication from reflexive signaling to intentional information transmission, a threshold crossed by only the most cognitively sophisticated animals. Human language has recursion, the ability to embed phrases within phrases. The dog is a phrase. The dog that chased the cat is a bigger phrase containing the first. The dog that chased the cat that ate the mouse embeds deeper. We can continue almost infinitely. For decades, linguists believed recursion was unique to human language, the feature that distinguished our communication from all animals. Scientists continue exploring whether similar patterns appear in animal communication. Some researchers have examined whether certain bird songs show hierarchical patterns, where phrases nest within larger phrases. While this remains an active area of study, the evidence suggests that birds organize their songs with remarkable structure, even if it differs from human grammar in important ways. The boundary between animal communication and human language invites us to wonder rather than draw sharp lines, each discovery revealing more complexity than we expected. Parrots in the wild use contact calls to maintain group cohesion while flying through dense rainforest. Each individual has a signature call that says, "I'm here," and flockmates respond with their own calls, creating a flying conversation that keeps the group together even when they can't see each other through the foliage. These calls are learned in juvenile social groups and serve as identity markers for life. Research tracking wild parrot flocks using acoustic arrays has revealed that parrots can identify dozens of individual flockmates by call alone and adjust their flight paths to maintain proximity to preferred companions. It's in-flight social networking, relationships maintained through constant vocal contact. The flock held together not by sight but by sound, by the reassurance of familiar voices saying, "Still here, still with you," still together through the green maze of the forest canopy. Orcas have been observed teaching their young specific hunting techniques through demonstration, practice, and what appears to be encouragement. In Patagonia, orcas intentionally strand themselves on beaches to catch seals. Mothers bring calves to these beaches and demonstrate the technique repeatedly, sometimes pushing reluctant calves toward shore, other times catching a seal and releasing it near the calf so the calf can practice. This is pedagogy, deliberate teaching, knowledge transmission from expert to novice. The vocal communication during these sessions is constant. Researchers have recorded specific call types that seem associated with teaching contexts, though the meaning of these calls is still being decoded. What's clear is that orcas don't just pass on knowledge through genes or passive observation. They teach, actively and intentionally, using communication to guide learning. Culture flowing from generation to generation through the medium of patient instruction. The separation between communication and language isn't sharp. Instead, there's a gradient. At one end, simple reflexive signals, a plant releasing chemicals when damaged, a cricket chirping when temperature reaches a threshold. These are communication. But there's little flexibility, little learning, little room for variation. Move along the gradient and you find learned signals, animal calls that must be memorized. Further still, signals combined in sequences to create new meanings. Further, signals that refer to things not immediately present. Further, signals that can be used to deceive, to teach, to plan. At some point along this gradient, we might call it language, but the threshold is gentle, defined differently by different researchers. Some say only humans have language. Others say great apes have primitive language. Still others argue dolphins and whales qualify. What's real is the gradient itself. Complexity increasing smoothly from simple to sophisticated. No sharp boundary, just a continuous spectrum of communication, becoming language, becoming thought made shareable. One theory suggests human language evolved from gestural communication, though other theories suggest vocal and gestural language co-evolved together. Our closest relatives, great apes, gesture extensively but vocalize less flexibly. Our ancestor might have first developed a rich gestural system, then gradually incorporated vocalization as our vocal anatomy evolved. Supporting this idea, human infants gesture before they speak, pointing and reaching to communicate desires. And all human languages, signed and spoken, share core features like syntax and recursion, suggesting they stem from a common underlying capacity. Language, in this view, might have begun with hands making meaning in the air, and gradually moved to include the voice, bringing ancient gestures along as the foundation. The reason we still can't help but gesture when we speak, hands remembering their original role as language's instruments. Bottlenose dolphins can understand televised instructions. In experiments, dolphins watched underwater televisions showing other dolphins performing behaviors, then successfully imitated those behaviors, demonstrating they understood the TV was showing a dolphin, not just meaningless moving shapes. They could also follow gestural and vocal commands to perform novel actions they'd never been trained on specifically, combining known behaviors in new ways based on instruction. This flexibility, this ability to understand and execute communicated instructions for actions never performed before, suggests dolphins have something like a mental workspace where they can manipulate symbolic information, planning action based on communicated ideas rather than just learned associations. It's communication enabling behavioral creativity. Language as a tool for collaborative problem solving. Crows can describe people to other crows using a combination of calls and pointing with their beaks. When researchers wearing specific masks appeared near crow territories, crows would scold those masks aggressively. But more interestingly, crows would sometimes fly to neutral crows and perform specific call sequences while orienting their bodies toward where the dangerous person was last seen. The neutral crows, following these signals, would then avoid that area. This is displaced reference. talking about something not immediately present, communicating about a specific entity to someone who hasn't encountered it, using directional gestures to clarify what's being referred to. It's sophisticated information sharing, closer to human-style reference than most animal communication. The crow is essentially saying, "Dangerous human. Over there. Be careful." Using calls and gestures together to create meaning. Some researchers suggest that whale and dolphin communication might be so different from human language that we lack the framework to understand it fully. We're looking for sequences of sounds that map to meanings, like words map to concepts. But perhaps cetacean communication works differently. Perhaps it's holistic rather than componential, with entire complex sounds representing complete ideas rather than building meaning from smaller parts. Or perhaps they encode information in aspects of sound we're not measuring yet. Recent AI approaches to analyzing whale sounds have found patterns human researchers missed. Structures in the data that suggest meaning but don't map neatly to anything in human language. We might be like someone who doesn't know music trying to understand a symphony. We hear sounds. We detect patterns. But the meaning might elude us because our categories don't fit their reality. The ocean might be full of conversation we're still learning to hear. The study of animal communication reveals how much human language depends on shared context and unspoken assumptions. When a vervet gives the eagle alarm, it works because all vervets share an evolutionary history with eagles as predators, share a body design that makes diving into bushes an appropriate response, share a social system where alarm calling is understood and responded to. The meaning isn't just in the call, it's in the shared world, the call references. Human language is the same. Our words work because we share culture, biology, experience. The word tree means something because we've all seen trees, have tree-shaped concepts in our minds. Without that shared context, words would be empty sounds. Animal communication makes this explicit, showing us that all language is contextual. All meaning is created by speaker and listener, drawing on shared knowledge. We understand each other not just because we know the words, but because we share a world those words describe. Birdsong is sometimes described as the closest thing to human music in the animal kingdom. But it's perhaps more accurate to say human music is one variant of a broader phenomenon of acoustic display found across many species. Whales sing, gibbons duet, wolves howl in chorus, coyotes yip in synchronized groups, and many species of birds produce sounds we'd call musical. All these share features: repetition, patterning, rhythm, pitch variation, emotional impact on listeners. Music, broadly defined, might be any aesthetically patterned sound used for communication or social bonding. By that definition, music is ancient and widespread, far older than humanity, a mode of communication that perhaps preceded language. Sound used not just to convey information, but to create feeling, connection, beauty. Our symphonies and songs are elaborations on themes nature has been exploring for millions of years. Elephants respond to human voices even when the speakers aren't present. Playing recordings of voices from speakers hidden in the bush triggers the same responses as seeing those people directly. But elephants can also distinguish between the voices of different ethnic groups who pose different threat levels, and between men, women, and children. This suggests elephants process human speech at a level of detail that extracts information about identity, gender, age, and cultural group membership from acoustic properties alone. They're reading our voices the way we might read facial expressions, extracting social information from sound patterns. In their minds, our voices carry meanings beyond our words, communicate things we don't intend. Age, gender, threat level, cultural identity, all encoded in pitch, rhythm, intonation, and extracted by elephant brains analyzing us in ways we don't analyze ourselves. Some fish produce sounds using their swim bladders as resonating chambers, creating communication systems based on drums and hums rather than vocal cords. Midshipman fish along the Pacific coast hum during mating season, males vibrating their swim bladders to produce droning calls that attract females. Different males hum at different frequencies, and females prefer particular frequency ranges. It's sexual selection driving signal evolution. Female choice shaping male signals across generations. But it's also a reminder that language, broadly construed, isn't limited to a specific body part. Birds use a syrinx. Mammals use a larynx. Fish use swim bladders. Crickets rub their legs together. Nature has invented sound making dozens of times, in dozens of ways, each time using whatever body parts were available and could be modified to produce communicative noise. The specific mechanism doesn't matter. The function does. Making sound, broadcasting information, reaching toward other minds. Humans have an unusually descended larynx compared to other primates, a design that increases choking risk but allows greater vocal flexibility. This anatomical change happened relatively recently in human evolution and might have been driven by sexual selection for vocal ability or by natural selection for improved communication in increasingly social groups. Either way, we sacrificed safety for sound. Other primates can't produce the range of sounds we can because their vocal tracts are shaped differently. Our throat remodeled itself to serve language. Evolution choosing communication over safety, betting that the benefits of complex speech outweighed the costs of occasionally choking. Our anatomy is shaped by words, bones and muscles rearranged to serve the demands of meaning-making. We are built for language in ways our ancestors weren't. Our bodies testifying to how essential communication became to human survival. Birdsong research contributed significantly to neuroscience and the understanding of brain plasticity. Studying how songbirds learn, remember, and produce complex songs revealed that adult brains can generate new neurons, a discovery that overturned decades of dogma claiming neurogenesis stopped after early development. The bird brain regions responsible for song learning became model systems for understanding how brains encode and produce learned behaviors. Techniques developed to study birdsong influenced human language research, showing commonalities in how brains handle sequential learned behaviors. The birds taught us about ourselves, their small brains revealing principles of learning and memory that apply across vertebrates, reminding us that we're not unique in how we learn, just in what we learned. The more we study animal communication, the harder it becomes to define what makes human language special. Every feature once claimed as uniquely human has been found in some animal system. Symbolic reference, bees. Vocal learning, songbirds and cetaceans. Syntax, possibly in some form. Displacement crows. Theory of mind, chimps. What seems to be special is not any single feature, but the combination and degree we do all these things, integrated together, to an extent no other species matches. Our language is quantitatively different, more flexible, more expressive, capable of discussing literally anything. But it's not separate from nature. It's built from pieces found throughout the animal kingdom, assembled and refined by evolution into something that, while remarkable, has clear antecedents in the communication systems of our relatives and neighbors. We're special, but not separate, connected to all communicating life through shared ancestry and shared needs. Whale songs change over time in patterns similar to human song trends. New phrases are introduced, often by younger whales. And if those phrases are attractive, they spread through the population, sometimes replacing older phrases entirely. Research tracking humpback whale songs across decades has documented song revolutions where an entirely new song type sweeps through a population over just a few breeding seasons. The mechanism is cultural evolution, ideas spreading through social learning, selected for by attractiveness to listeners. It's the same process that drives human music trends. When new styles appear, catch on, become popular, and eventually are replaced by the next innovation. Whales have culture, fashion, trends, their songs evolving in real time, each generation building on the previous while adding innovations. The ocean's music library constantly updating, refreshing, reinventing itself through the collective creativity of singing males. Human children's language acquisition follows stages remarkably similar to how young songbirds learn their species' songs. Both start with a sensory learning phase, listening to adults without producing much themselves. Both then enter a sensori-motor phase, producing imperfect imitations that gradually improve. Both have critical periods where learning is easiest and produces best results. Both require social interaction, not just passive exposure, for optimal learning. These parallels suggest that vocal learning, whether for language or song, relies on similar neural mechanisms and developmental processes across species. Understanding how birds learn songs has directly informed theories of how children learn language, revealing that the capacity we think defines humanity. Language might actually be a specialized version of a more general vocal learning ability that we share with birds, whales, and a few other scattered species across the tree of life. Dogs have evolved special muscles around their eyes that allow them to make expressions that wolves lack. These muscles let dogs raise their inner eyebrows, creating an expression that humans find appealing and interpret as sadness or pleading. This is a communication adaptation that evolved specifically for interacting with humans. Dogs that could make these expressions got more care and resources from humans, passing on their genes. Over thousands of generations, dogs' faces physically changed to be better communicators with us. It's co-evolution of communication, humans and dogs shaping each other, their language becoming one that crosses species boundaries. When your dog looks at you with those soulful eyes, it's using a communication system built by 15,000 years of dogs figuring out how to talk to humans in ways humans cannot resist. The existence of animal communication systems as complex as whale songs, elephant rumbles, and chimp gestures invites us to wonder if communication can become this sophisticated without grammar as we define it, without written language, without symbolic thought as we understand it. Then what does language give us that whales don't have? One answer is generativity. We can say things never said before, combine words in new ways to express novel thoughts, talk about hypothetical situations and distant futures. Animals mostly communicate about the present, the immediate, the concrete. We communicate about possibilities, abstractions, the contents of each other's minds. Language gave us the ability to think together, to pool thoughts, to build ideas collaboratively across individuals and generations. Not smarter individually, perhaps, but smarter collectively. Language as the technology of collective intelligence. That might be the difference. Not that we communicate. Everyone communicates. But that we can think together in ways other species cannot. Yet, you might be feeling tired now. That's exactly right. Breathe slowly and think about cycles. Animals live in cycles, calling and listening, signaling and responding, teaching and learning, generation after generation. Whale songs change with the seasons. Bird dialects drift across years. Elephant matriarchs pass knowledge to granddaughters, who will lead herds decades from now. Communication is a river, always flowing, always changing, yet somehow remaining itself. The song transforms, but the singing continues. The caller dies, but the call persists. Learned by the next generation, carried forward. You are also part of these natural rhythms. Your body knows them, the cycle of breath, the cycle of waking and sleeping, the cycle of energy rising and falling through the day. You don't need to fight the tide. Just let it carry you. Like animals, settling into rest after a day of calling, singing, signaling. You can settle too. The conversation will continue tomorrow. Tonight, silence is enough. We're almost there now. Almost home. Every animal that communicates reaches toward the same thing, connection. To be understood, to affect another being, to transform thought into signal, and have that signal recreate thought in another mind. A whale singing alone in dark water, hoping somewhere distant, another whale hears and answers. That's courage. That's faith. Broadcasting self into vastness. Trusting the ocean will carry your voice to someone who understands. When bees dance, they say, "I found something worth sharing." When birds sing, they say, "I'm here. This is my place." When dolphins whistle, they say, "You have a name, and I remember it." Young elephants learn to speak through patient teaching from grandmothers who remember droughts from 50 years ago. Knowledge flowing through generations, not in books, but in rumbles and touches, in the slow transfer of understanding. Crows warn each other about dangerous humans for years after a single encounter. That collective memory, that shared knowledge network, keeps the community safe. Communication stores the past and projects it into the future. Some birds sing songs they learned from foster parents of different species, mixing elements from both their genetic heritage and their acoustic environment. Identity becomes fluid, shaped by learning rather than genes. Who you are depends on who taught you. The first words human children learn are usually social mama, dada, hi, bye. Not objects, not actions, people and connection. The first concepts we mark with language are relationships, recognizing that language exists primarily to bind us together. In the Amazon, Monkey species share a common language of alarm. When one calls danger, all respond, regardless of species. Capuchins, tamarins, howlers, each with their own voice, yet all understanding the universal word for threat. The forest becomes one community, boundaries dissolving in mutual protection. Parrots mate for life and develop unique duet patterns with their partners. Each pair's duet is distinctive, their own private language, refined over years. When one partner dies, the survivor sometimes continues singing their duet alone, calling for an answer that will never come. Fireflies synchronize their flashing across entire trees, thousands of individuals blinking in perfect unison through mechanisms we still don't fully understand. It's communication becoming art, function transcending into beauty, the conversation itself becoming the message. Human babies recognize individual voices before birth. They learn their mother's voice in the womb, responding to its rhythm and intonation. We enter the world already listening, already learning language. Communication beginning before first breath. Some dolphin populations have unique whistles that function like family names, passed from mothers to calves across generations. Acoustic lineages stretching back through time, each dolphin carrying the sound of their ancestry, their pod's history compressed into a whistle pattern. Wolves adjust their howls based on wind direction, pitching their calls to maximize travel distance given current conditions. Even in something as instinctive as howling, there's adaptation, learning, optimization, communication, refining itself through environmental feedback. Gorillas use chest beating not just for aggression, but as identification. Each male has a distinctive rhythm and tone to his chest beat, recognizable to other gorillas across distances. Researchers can identify individuals by their drumming pattern alone. The sound travels through the forest, announcing presence, signaling strength, claiming territory through percussion. In laboratories, animals have been taught rudimentary symbolic systems. Chimps learned sign language. Parrots learned words. Dolphins learned gestural commands. Each time, the animals demonstrated they could map arbitrary symbols to meanings, showing the cognitive foundations for language exist beyond humans. When researchers play recordings of elephants' deceased family members, living elephants react with recognition and what appears to be grief. They remember the voices of the dead. Communication survives death, preserved in memory, called forth by sound, connecting past to present. Birdsong dialects can be used to trace bird population histories, showing where groups split, mixed, and migrated. Language preserves history, carries it forward encoded in patterns, allowing us to read the past in the present sounds. Every dialect is an archive. Some whales modify their songs when background noise from ships makes communication difficult, raising pitch or amplitude to be heard above the din. Adaptation in action. Language bending to serve its function despite interference. The need to be heard overcoming obstacles. Human children and young chimps both use pointing gestures to direct attention, one of the earliest forms of communication. The gesture says, "Look where I'm looking. See what I see." It's joint attention, shared focus, minds coordinating through the simple act of indicating direction. In every language ever studied, human or animal, there are signals for danger. Warning is universal. The need to tell others threat approaching. Take action crosses species boundaries. It's communication in service of survival. Perhaps the first function that made language worth evolving. Sperm whales can adjust their click patterns to compensate for echoes in different underwater environments, essentially changing dialects based on acoustic geography. Communication, adapting to place. Language shaped by the spaces it fills. Meaning molded by medium. Some researchers suggest consciousness itself might require language. That self-awareness emerges from the ability to narrate oneself, to tell a story about the self to oneself. If true, then language doesn't just communicate thought, it creates the thinker. When human infants babble, parents respond, creating conversational rhythms before words exist. The structure of dialogue, turn-taking, call and response, precedes meaning. We learn language's form before its content, practicing the rhythm of conversation with nonsense sounds. Every signal sent by every animal for billions of years has been an attempt to answer loneliness with connection, to broadcast self and receive acknowledgement, to prove to the universe that I am here, I exist, I matter, and perhaps the most beautiful truth we're learning to communicate with them. Decoding whale songs, learning chimp gestures, training AI to translate animal signals. The barrier between species is beginning to dissolve. Not through evolution, but through compassion, curiosity, and science. We're working toward a day when we might truly understand what animals are saying, when the conversations that have surrounded us throughout our evolution might finally become intelligible, when instead of studying animal communication, we might simply communicate with animals, joining the planetary conversation that's been happening without us. Finally learning to listen to voices older and stranger than our own. And so, our quiet journey through the languages of the animal kingdom comes to a gentle close. We've traveled from whale songs, traveling through ocean darkness, to bee dances mapping flowers in geometric precision, discovering along the way that communication is the thread connecting all life. The impulse to reach out and be understood. From elephants remembering voices across decades, to fireflies writing light across summer nights, we've glimpsed how every species speaks in its own way, all saying fundamentally the same thing: I am here. Can you hear me? Are you there? We've met creatures that warn, that teach, that name each other, that lie and love and remember through their signals, reminding us that language in its deepest sense isn't human. It's alive, older than our species, belonging to the community of all beings trying to connect across the vast loneliness of individual consciousness. Animal language reminds us that we're not alone in the need to be heard and understood. Much of the world's conversation happens in frequencies we cannot hear, in chemical signals we cannot smell, in gestures and colors and dances we barely notice. They teach us humility, that communication takes 10,000 forms, and our words are just one variant among many. Without their languages, the world would fall silent, lose coordination, fracture into isolated individuals. Communication keeps the world connected. By honoring all forms of language, by learning to listen to voices unlike our own, we join the conversation life has been having for billions of years. Add our voice to the chorus, and remember that speaking and listening are how we transcend the prison of self and touch other minds in the vast, shared space of meaning. In these final moments, take the deepest breath you can. Think about connection. Every language, human and animal, bird and whale, gesture and chemical and song, all doing the same work, transmitting thought, creating understanding, building bridges between separate minds. You are not separate. You are one voice in the planetary conversation, one signal in the vast network of communication that binds all living things together. The animals we explored tonight, each one reaching toward others with their particular language, each one saying, "I exist. Do you exist? Let's exist together." Whale songs and dog barks and ant pheromone trails, all variations on that same theme. Connection, community, the end of isolation through the magic of shared meaning. Let your entire being dissolve into the web of communication that surrounds you. Always. Invisible threads of signal and response linking everything that lives. A conversation older than continents, quieter than silence, louder than any sound. The language of life talking to itself through all its forms. And you part of that conversation. Always have been. Always will be. Speaking and listening in the endless dialogue of existence. Prepare for deep sleep. No boundaries left between you and rest. Only peace. Only breath. Only the soft darkness welcoming you home. If this gentle journey through animal language helped you feel connected to the natural world tonight, perhaps pass this along to someone who loves nature and needs rest. Your quiet support helps other curious souls discover this peaceful space. One soft share, one peaceful night, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've journeyed far tonight through the world of animal communication. You can allow these thoughts of signals and songs to fade now, like the last calls of evening birds settling into sleep, leaving only quiet and the deep peace of connection acknowledged. Let your breathing deepen. Let your body feel heavier, like an animal returning to its den after a day of calling, signaling, singing, ready now to rest in the silence that all languages eventually return to. If sleep comes, let it carry you like nightfall quieting the forest, smoothly, inevitably, into the realm where all conversations pause and consciousness dissolves into the shared darkness of universal rest. If your eyes are still open, another journey waits for you, ready to continue. But if they're closed, stay there. Stay in that soft silence where all beings eventually rest, where language stops and simply being is enough, where nothing needs to be said because everything is already understood. Tomorrow, whales will still be singing their ancient songs. Birds will still be teaching their young. Elephants will still be rumbling to each other across the savannah. The great conversation will continue its eternal flow. But tonight, you've listened enough. Tonight belongs to silence, to rest, to the peace that comes after words. Sleep well, gentle soul, and remember, you are part of the conversation. Always have been. Always will be. Your voice matters. Your listening matters. You belong to the speaking world, and the speaking world embraces you. Relax, listen, and drift with the animal kingdom. Good night.